So in the previous video, we started with the basic idea as to why quantum mechanics had come in. The reason being the dual nature of matter, which was not considered by classical mechanics. In this video, we're going to be talking about hydrogen atom and Schrödinger's equation. So when the Schrödinger's equation was solved for the hydrogen atom, it gave us the information about the various energy levels that the electron can occupy. Okay, so this particular value was called as an eigenvalue. Okay, so these values of energy of psi were called as these were called as eigenvalues, whereas the corresponding wave functions, that is psi, okay, the energy is not psi, E is energy. So the corresponding wave functions is called as the eigenfunctions. So first, when it was solved, it gave us the various possible energy levels that an electron can occupy. So what happened was they correspond to the values wave function. The wave function basically is characterized by three quantum numbers: the principal quantum number n, the azimuthal quantum number L, and the magnetic quantum number, which is m. And these are basically, they came up because of the solution of the Schrödinger's equation. So what happened was, these first of all, these various quantum numbers will be discussed in detail in, I think, the next video. And the reason they came up was because of the solution of the Schrödinger's equation. Not only that, the quantum mechanical model is able to tell us or give us the information as to why or explain the hydrogen spectra and various other phenomena which happened, which were not explained by Bohr, but also explained by the quantum mechanical model. Now, the major issue with Schrödinger's equation is it cannot exactly be calculated for the multi-electron system, but you can actually there is a lot of difficulty, but using computers they were able to calculate that the other atoms do not differ from hydrogen in any major way. The major difference between the other atoms and hydrogen is the variation in nuclear charge. So when there is an increase in nuclear charge, there's obviously going to be difference in energy, which again we will be learning about in after a few videos. So basically, according to all of this, it meant that an orbital, there was a new word that had come in, that is an orbital. So an orbital is basically the place around the nucleus where the probability of finding the electron was maximum. So here in Bohr's theory, he talks specifically about the fact that electrons have a fixed path. But from our understanding of Heisenberg's uncertainty principle, we could not exactly point out that this is going to be a path of the electron. However, according to Schrödinger's equations, they were able to figure out the position or the area around the nucleus where the probability of the electron was found is maximum, and that was called an orbital. So we learned about the hydrogen atom and the Schrödinger's equation. Principal quantum number, azimuthal and magnetic quantum number will be dealt with again after a few videos. And the important thing we need to remember over here is the concept of orbitals, which had come in thanks to Schrödinger's equation, and this did not point out the exact path of an electron, but it said that an orbital is going to be a place where finding the electron or probability of finding the electron was maximum. So then in the next video, I believe we will be learning about the various features of the quantum mechanical model.